What did we do last time? We had some pizza and beer we were working on, and we mapped out the production possibilities frontier, and we had something that looked like this. I won't maybe redraw everything perfect. And it was showing the maximum combinations of two goods. Our two goods were the quantity of beer and the quantity of pizza. One thing when you're dealing with an economic model to be aware of right out of the gate is, what are we measuring on the axes, right? Kind of keep that in your mind right away as you start to pin things down. And then as you look at a line on there, whether it's a supply curve, or demand curve, or something, whatever we're talking about, I'd like you to start to get comfortable with whether that's a positive relationship or negative relationship between those two variables. Is this a positive or negative relationship between these two variables, quantity of beer and quantity of pizza, the production possibilities frontier?
Negative.
Negative. How do you know that? The slope. Okay, so that's kind of the mechanics back to the slope. We don't have to dive into the slope either right away, but we can think about, this is the way I like to do it a lot of times. As the quantity of pizza goes up, the quantity of beer goes up or down? Down. Or as the quantity of beer goes up, the quantity of pizza goes down. They're always moving in opposite directions. That's kind of a helpful way to think about positive, negative relationship, even if, hopefully you'll start to get the whole picture together, because you are correct, a negatively sloped line means that it's that negative connection between. One goes up, the other goes down. We see that graphically by moving around on this thing, like last time we had, I might pick off a few things that you guys should have in your notes from last time. We went from, and now this is not drawn to scale as good as I did last time, we went from this point to 4 and 7 to 5 and 0. These were 2 points on your production possibilities frontier. And there was a connection to the trade-offs via the slope and its opportunity cost. So how far did we get on our opportunity cost line? I remember I was writing out the opportunity cost of the first this, the second this. What did we get to? Did we just go to 12 on that?
We got stuck on the 4 and 1 7.
4. So what was it? Was the I'll just go ahead and write it out here so you guys can. The opportunity cost of the first, and it was beer. We had pizza ahead of that, so I'm kind of catching up here. The first beer is 1/7, right? So we had that kind of weird thing going on where we were looking at a fraction of a pizza because the first beer is right here. And in order to get the first one, I have to give up a 7th. We were kind of estimating with the data that we had here that it was a 7th. And then I went to kind of push your brain a little further, and I said, what did I say, the second or the third?
Third.
Third. So we have the third beer is the same thing, which tells you something of what we're doing with the slope between this point and this point. What's true about the slope between this point and this point? It's consistent, it's the same, right? So what we've really done, and maybe I should back up one step, the theoretical production possibilities frontier is a nice curve. You're going to see that in the books, right? It's a nice smooth curve. But when I give you what we call discrete data of just the schedule goggles, where it's this point, this point, this point, we're really making an assumption that between these 2 points, it's a perfectly straight line. And what is the slope of that line? What's the slope of that line between these 2 points, that one and that one?
1/7.
Careful.
-7.
-7. And strictly speaking here, we do the good old rise over run is my favorite way of remembering that. We're going down 7 over 1. Down 7 over 1 to figure out that number. Down 7 means -7. Down 7 plus 1. Slope is negative 7. Slope is negative 7. Okay. That's why when we figured out the third, the fourth, the fifth, all of those trapped in here, we're just going to say, you know what? We don't have enough information to work with. They're all roughly equal to a seventh of a pizza. Then we moved on to what? 12. So I jumped it up. Is that where we stopped? Or? Yeah. So the 12th beer was how much? Or is that where we stopped? Oh, we got hung up. That's right. That was awesome. Okay. So what is the opportunity cost of the 12th? 2. I don't have my numbers here. Maybe I need to. Let's see. We got. I'll eyeball this. This is going to get ugly. Maybe I should have just drawn this nicely to begin with. But 12 and 3. Your guys' graph should be a lot better looking than this. What are we at the next one? 16.
16 and 2.
16 and 2.
19
So this is where you got to put the little squigglies in here. 19 and 1. See, perfectly spaced out here. 1, 2, 3, 4, 5. But remember, I wanted you guys to go nice spacing 1, 2, 3, 4, 5 between those. And so we've really established these points on the production possibilities frontier. So now I'm looking for what is the cost of the 12th beer? 1 and 5/7. What do you think?
That'd be 2 pizzas.
That'd be 2. So we got to think to ourselves, what does it mean to look for the cost of the 12th? What's kind of underlying that language? How many do you have already? 11. So the cost of the 12th is the cost of an additional 1 unit. Where does the 12th live? What interval are we on? I kind of picked a tricky one here because I put you right on the spot. Are we going from 7 to 12? Or are we going from 12 to 16? What interval are we on as we start to think through this process of wanting to calculate the cost of the 12th? 7 and 12, right? So again, if you want, you could, and we labeled all these, we have the 11th right there. So visually, we're kind of at this point, 11, and this would turn out to be a fraction. I'll just leave that for now, not to complicate things, but what is it costing us to get the 12th beer, right? Again, all I know is that that's in this interval where I know for sure I can trade, let me do that over here, 5 beers equals, over this interval, I can add 5 because the 11th is trapped in there. I can add 5. It's going to cost me 1 pizza. I'm not interested in the opportunity cost of the next 5 beers. I want the opportunity cost of the 12th, specifically 1. How do I get a 1 over here? Divide by 5. What do I do to one side of the equation? I got to do the other side. Boom. 1 beer equals a 5th of a pizza. So the opportunity cost of the 12th is a 5th. We're going to do a few more, so if you're still foggy on this, well, how about the opportunity cost of the 13th beer? 1/4. Okay, so the 13th lives right here. I don't have data from your schedule goggles of what goes on exactly between those, so I'm going to estimate. Over this interval, I know that I can trade 4 beers, 12 to 16. I can make that jump. If you look back in your notes, remember when we did the schedule, yeah, you got it. I didn't make all the, you might want to go down the, yeah. In fact, it looks like somebody did it. I can't remember if I did or not. But let me just take the time here to, let's see, quantity of beer. I'm just rewriting what you should already have in your notes already. So Let's see, we got 20, 0, 19, 1, 16, 2, 12, 3, 7, 4, 0, 5. Okay, so there's your schedule in numbers. And all we're thinking about is the trade-offs each time. I want a pizza, I have to give up a beer. I want another pizza, I have to give up 3 beers. I want another pizza, I have to give up 4 beers. I want another pizza, I have to give up 5 beers. I want another pizza, I have to finally give up 7 beers. Okay? Maybe this is as good a time as any to think about whether that makes sense at all in terms of why that's happening. What's happening to the cost of pizza as we acquire more and more of it? Look back at your pizza numbers. I don't have it here, but the opportunity cost of pizza, it's the one that's above this. It increases, right? It goes up. In fact, we saw that right here. Well, it used to cost me only beer, but geez, now it's costing me 3 beers. Well, geez, now it's costing me 4 beers. Well, geez, now it's costing me 5 beers. Okay, good question. That's what I want to talk about. Is it because of quantities? Is it because of quality? I mean, is this because, well, now I'm giving up a Heineken. Up here, I was just giving up a Natty Light. That wasn't too big a deal.
Supply and demand.
So, no, we're actually just focusing in on kind of supply only, production.
You have 25.
This is really at the heart of the issue.
Inflation.
What's the definition of the production possibilities frontier?
Max combination of 2 goods is constantly produced given its available resources.
Okay, nice and loud, especially on that last part. What's the last part, the given?
Shows the max combination of 2 goods an economy can produce given its available resources and technology.
Given its available resources and technology. So let's put on a reality hat here. So this is really pizza. You guys know what goes into a pizza, right? We got some bread, we got some crust, we got some tomato sauce, we got some pepperoni, we got some cheese. Okay? And up here, we've got beer. We've got some water, we've got some barley, we've let it stewed, we got a big kettle that we let the beer ferment in for a while and get that alcohol all juiced up, right? So I just want you to kind of visualize that. Now, as the economy, which could be Tom and Jen on an island, or it could be 300 million people on it, as the economy moves from this point to this point, and finally to this point, tell me what we're making pizza out of.
Beer product.
Beer products, right? Beer resources. Resources that are really better for beer production, right? So that big old kettle that we were fermenting the beer in, now we're using for tomato sauce stirring or something, right? So it doesn't really work that well, but what else are we going to do with it? And then we start making barley crust or something. Maybe that's good. Maybe that's a new innovation. I don't know. But what we're doing is we're slamming resources into this particular good pizza. There's brewers who are very talented at making beer. Now they're tossing crust. Is that an efficient use of their time, or is it kind of costly in terms of how much beer we're giving up? Because now when we flip this around and we move this way and we say, you know what, I'm getting kind of thirsty, I need myself a beer, we're freeing up those resources, and guess which ones we're freeing up first? Who's the laborer that leaves? The brewer, the person who's good at brewing, right? And we get that, boom, we get that big jump in stuff because we're putting resources to use in a better spot. Just like we saw with Tom and Jen on the island, we're putting those resources to better use in the economy, and that's what gives this changing thing. Now look at what happens again as we move this way. We're starting to get to, well, how about we got to put that pizza sauce in something, we'll have a tomato beer, okay. Right? So when we move to this extreme, where we're producing all beer, once again, we're slamming resources that are better suited to pizza production, we're focusing them on beer. And so once again, when we reverse that, when all of a sudden we say, okay, that's kind of dumb, I'm getting kind of hungry now, I free up those pizza makers, I free up the capital that's better suited towards pizza production, and boom, I get a big jump. Now in this case, I had this all constant, but in our normal case, we would expect kind of the same thing going on in the pizza direction. Okay? That's the idea of this bowed out production possibilities frontier. All right, so you guys correctly said that this would be a fourth of a pizza, because over this interval, 4 beers are being traded for 1 pizza. I want the opportunity cost of 1 beer. It's a fourth of a pizza. All right, opportunity cost of the 18th. 18th. 1/3, good. So now if we use our schedule goggles here, we can say, well, the 18th is trapped in this interval. Over this interval, I know that I can trade 3 beers for the 1 pizza. I'm not interested in 3, I just want 1, and it equals 1/3 of a pizza. All right, opportunity cost of the 20th is 1. There we're back to that 1-to-1 trade-off. All right, so let's see. Does this work in the opposite direction? Is the opportunity cost of beer getting larger or smaller? We've got fractions involved here, so a 1/7, a 1/5, that's getting smaller, bigger. Okay, I know we don't all digest fractions the same way, so if you have to, sometimes I did this on a test. I remember when I was freaking out, a little test anxiety or something, pull out a calculator. What's 1 divided by 4? Right? But it's 0.25, 0.33, 0.2, right? So it is increasing, 20 cents, 25 cents, 33 cents, and all the way up to $1. So we got the same thing going on with both goods. The opportunity cost is increasing as we produce more and more of that good. All right, so I saw a question maybe before I go, or you good?
If we were going the opposite way, we just turn the fraction around, right? It's going to be 3, 1, 3, 4, 5, 7, 7.
Yes. The opposite, like we did last time, we did get 1, 3, 4, 5, 7. Is that what you're talking about? Yeah, it is the inverse of each other. So that's another reason I like to draw that out. If you look at all those numbers, they're just inverses of each other. Another thing that's kind of a nice little tidbit, I'll write some of this down. The slope of the production possibilities frontier is equal to the opportunity cost of whatever you're measuring on the horizontal axis, right? Over this angle, the opportunity cost was 7, and that's what we had for the beers, one of your line items there. So opportunity cost and slope are one and the same. They're kind of related to each other. All right, so let me put on the question of why. This is a great test question. Why is the PPF bowed outward? Why is the production possibilities frontier bowed outward? Some resources are better suited. Some resources are better suited for the production of one good or the other. Some resources are better suited for the production of one good or the other. Some resources are better for pizza production. Some resources are better for beer production. And that's why we get this bowed out look to the production possibilities frontier. So note, this creates another interesting little law in economics. the law of increasing cost. This creates the law of increasing cost. Let's just take the quantity of pizza graphically on the horizontal axis, and the quantity of beer again up here. But I'm going to graph something different this time. I want to graph what we call the marginal cost curve, or I want to graph those costs that we had. So go ahead and put 1, 2, 3, 4, 5, 6. Well, you don't have to go to 6, I guess. 1, 2, 3, 4, 5 is fine. And over here, don't go up to 20 because of the way the numbers work, but let's go just for, so we have something to go by here, 0.25, 0.5, 0.75, and 1. These are fractions of a beer. The cost of the first pizza was how many beers?
1. Well, now it's 0.25.
So the first pizza, 1 to 1? 1 to 1. All right. So you know what? I think I screwed this up because I was thinking about going the other direction. Because now we're going to be going up.
Beers over pizza, right?
Yeah, and I'm just going to keep this and let you guys be bad at me for quantity. We're still doing beer, so this is staying the same. I'm just reorganizing my thoughts here. You're right, it is 1, 2, this is where you're going to hate me, 3, 4, 5, 6, 7. We're going to rescale that vertical axis. Sorry. So that first pizza cost us a beer. The opportunity cost of the second pizza, 3 beers. So plot that point at 3. The opportunity cost of the third beer, or third pizza, sorry, 5, right? All I'm doing is pulling right off the stuff. I just wanted to plot exactly what we did last time. The cost of the fourth pizza was 6. And the fifth finally was 7. If we take the liberty of just connecting these dots, we have the law of increasing costs. We're thinking about the cost associated with the incremental unit. This is the marginal cost curve, which we'll talk a lot about this semester. The cost of an incremental pizza. What are we really giving up at the margin, the extra one? Okay, and so this last note that I already said, I want to make sure you get it down in your notes, is a double check. So note, the opportunity cost, this will really help you out on some of the homework problems and test problems. The opportunity cost of whatever you measure on the horizontal axis is equal to the slope of the production possibilities frontier. Now, do we got any math majors in the room here? No, man, you are a little bit. I'm not going to pick on you too much, but I thought you were kind of fidgeting in your seat a little bit because this statement's not quite right if you're a math person, if you're really into the specifics of math. It's really equal to the opposite of the slope because that sucker is always negative, right? But the cost is actually expressed as a positive. But I told you, this isn't math class. This is econ class, like real life, and we're going to have practical applications. So I'm going to ignore that little math thing, but I have to kind of settle those butt clinchers that were math people in their seats so that they don't get too worked up about it. But technically, the most technical way to say this would be it's equal to the opposite of the slope. But I found that confuses most of the non-math people, so I've just kind of gone equal to the slope. All right, so that's kind of helpful as we move on. All right, so let's move on to a little bit more general. So let's put general comments on the production possibilities frontier. General comments on the production possibilities frontier. All right, so one, we usually show it as bowed out with a curve, even though we've kind of shown you some of the things, some of the liberties we're taking depending on how it is. So if we were to put the quantity of beer up here and the quantity of pizza down here, we would have a nice smooth curve. Which brings up kind of an interesting wrinkle when you get into slopes. Who remembers how to take the slope of a curve? Go ahead. Todd?
Oh, do I just say it?
Yeah.
Oh, okay. You draw your the line that goes straight across the point that you want to.
Okay. What do we put? What do we call that line?
Tangent
The
line.
tangent line. Well, in econ class, that is actually a golf club. All right. So you guys are wondering, is the golf club's coming into play? This is a multifaceted tool. This is my piece of capital that I have for teaching economics class. And so, what happens to the slope of the curve at different points? If I was to look at point A or point B, it increases. And from what we just said about this connection between slope and opportunity cost, does that work? Is it supposed to be increasing? As the slope gets steeper, the number gets bigger, right? So we go from a littler number to a bigger number. The rise over the run is bigger, like we saw here. We had the rise over the run as down 3 over 1. Down here, it's down 7 over 1. So that slope has changed. So this all works. This all works. But now, we're going to take a very, 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 very tiny change. In fact, we're just going to let it be kissing that point. So the tangent line is going down until it just kisses the production possibilities frontier. And then the slope of this line is the slope of the production possibilities frontier at that point A. And it's actually impossible to have another point. That's why we say just kissing. I just want you to visualize just coming down. There's no way that you could get a different slope. You can't rotate it. As soon as you rotate it, then it's actually intersecting it at 2 points. So we're just going to let it just drift down until it's just kissing that one point. And then the slope of that tangent line is the slope of the production possibilities frontier at that point. So at point B, the tangent line comes drifting in until it just kisses right there. And now I take the slope of that line, and that's the opportunity cost of pizza at point B. Right? All right, so that is a little thing with the curve. So when curved, the slope of the PPF is the slope of the tangent line at a single point along the production possibilities frontier. So if you want to, without your use of the golf club handy, you can put in like a little dashed line here, because you're just using that to kind of show the point that the orange line versus the red line, which might not be able to show at a distance, there's a difference in the slopes. It's getting steeper as we move down, and it's all kind of falling right into place with whether we had our schedule goggles or whether we have this continuous curve going on. All right, questions on that? All right, so next thing we need to look at is production possibility frontier shifters. What makes this thing move? What makes it go outward or change? PPF shifters. What's going to make this thing move off of its spot? More resources and new technology. So we had the definition read. The production possibilities frontier shows the maximum combination of two goods an economy can produce given its available resources, that's fixed, and technology. And then that's what allowed us to map out these points, because we held constant those things. Well, if all of a sudden I give you more labor or more capital or more resources, what's going to happen to this curve? It's going to grow, it's going to move out, right? So that's going to shift this thing out. Same thing with technology. As we have a new process or a new thing that we've come up with, it'll allow production possibilities that are greater. So number one, quantity of resources. Now, I put quantity down to kind of call that to your attention, that that's the thing that's really shifting it. It's not the price of the resources. Oh, it's just cheap labor. No, it's not prices. There might be an interrelationship, but at the very core of it, it's the quantity of resources. How much is in our bucket, right? We talked about the bucket of labor. If that bucket level fills, we have greater opportunities, right? We have economic growth. The production possibilities frontier really lies at the heart of economic growth. And now we start to see the linkages of why we call it that, is because with the production possibilities frontier, we have more pizza and more beer, right? So if our population didn't grow, which it does, but if our population didn't grow, then we are more prosperous. We all have potential to have more stuff, right? And so that's a good thing, is to figure out ways to have more final goods and services by using those things efficiently. So an increase in labor, for instance, leads to an increase in the production possibilities frontier, a shift out, a shift outward. So this notation, when I have an up arrow, that's kind of shifting outward for the production possibilities frontier. And this is an increase in labor leading to that. Number two, technology. Now, an increase in technology will also lead to a shift out of the production possibilities frontier. So for that one, I want to do a little bit of an example. I want you to suppose that there is a new machine invented that helps process crusts and rolls it out automatically, right? So there's a new machine that can help with the mass production of nice pizza crusts. Are we going to get more beer from that?
No.
No. Let's check it out. Let's graph it. So quantity of pizza, we're going to draw kind of the generic one. So this time you should redraw this thing. You can just draw some sort of ordinary initial production possibilities frontier.
But you have more beer, like labor resources.
Okay. So what do you mean? We can have more beer?
People that technically
You can't. The machine won't make more beer, but we'll have more resources to make beer.
Okay.
I would say the people that used to be the pizza rollers are now going to learn how to make beer.
Okay, good. So you guys are touching on the heart of the issue, is that these advances in technology, this is what's so doggone exciting about technological advance and why we want to put you guys in the butts of seats at institutions of higher knowledge so that you can figure out how to do it. And guess what? I don't care if you invent a computer chip, figure out how to make pizza better, or figure out how to make beer better, because we're all going to have more stuff because of it. And here's why. As we look at this shift, you guys correctly said that it wouldn't help beer production. But that's only correct in a very oddball circumstance, and that is if the economy is currently at point A. What does it mean to be at point A? We're at a peak. We're at a point on the production possibilities frontier, so we are productively efficient. It's focusing solely on beer. So if we are at point A, we're focusing solely on beer. Boom! New pizza technology. Is that going to help us get more beer if we are currently at 100 beers? Can we now have more beer? No. What happens with pizza? Let's take another endpoint, endpoint B, kind of an extreme case, and we're currently at 65 pizzas. Does that change this point?
Yes.
Yes. By how much? I don't know. It depends on the technology, but let's just say it ramps up to 110. Now, we can also start to free up some of these pizzas and get more beer, and we're going to have a function that looks maybe something like that. So there's the original PPF1, let's call it, with technology at its current level, and here's PPF2 with the new technology. Jeff?
Does that make your opportunity cost per beer more expensive?
It changes your opportunity cost as you move to a different point, yes. So that schedule of numbers would move. So if I had the quantity of beer, quantity of pizza numbers, all my pizza numbers would go up, and that would change those trade-offs for the calculations, yes. Basically, the slope of the new one doesn't necessarily connect to the slope of the old one. Those change. So here's the true excitement of economic growth. If we're at point A, I need to be at point C here, don't I? If we're at point C, rather than these two extreme endpoints, you guys nailed it. Those of you who are saying, oh, I get it, we can have more pizza if we just wanted to. How much beer did I have to give up? None. So I could move to a point like D, which is pretty sweet. I can keep my beer consumption at the level it was before, and I can chow down a lot more. Or I could be at a point like E. and I can have more of both. By freeing up some of the, as you said, maybe this machine allowed people to be freed up, and so some pizza makers lost their jobs, but the brewery was like, we're hiring, business is booming, people want our product, right? And so they go work for the brewery. And so there's a reallocation of resources between the final goods, and we could be at a point E, which gives us more of both. That's why I said, I don't care what you guys go out and invent. I want you to do it, even if I don't care about it. Because you're going to free up other resources for other things to be made, and we're all potentially made better off through an increase in the amount of goods.
Why does from C to E, why does it shift kind of diagonally versus just straight up?
I was picking one of an infinite number of points. Okay. So we could be here. Here's kind of an interesting point for you. Let me see, E, F. At point F, this pizza thing came out, but we're like, you know what? I'm maxed out on pizza. I'm trying to lose weight. I don't need any more pizza, and so I'm just going to swill some more beer. And hopefully that's less calories than all the pizza that I'm giving up, right? And so it's a net gain, and I lose weight. Kind of the beer diet. So you guys raised some good points here that if my initial point, let's go ahead and put a number on here. Let's say that this was, for fun, 60, and this was 43, right? So we were initially at 60 and 43. We could be any of these points. We could also be here. There's nothing stopping us from being at G or H or whatever. We can be anywhere. It's our choice. The choice, by the way, brings in the demand side. You know, as a society, where is society going to be? That's a reflection of what we want, what our preferences are.
It would be higher with, that's getting technical, but it would be higher with pizza since there's more pizza consumers than there are beer.
Yeah, that we don't know. We don't know for sure. This is purely on production. On the demand side, yeah, we can start to look at that. So if we're Canadians and we're drinking lots of beer, I don't know why that's probably not a fair thing because Americans probably drink way more beer than that, but we might choose to be at one of these points. And different countries, different cultures may choose to be at different points. Right? Over in Asia and China, they're not too big on alcohol, so they might choose to have more pizza. All right, more food. Ireland, they might be moving this direction. Good, thank you. I know there was some beer-swilling nation that I needed to come up with. All right, so another key point here with all of this is that, so key point, all points along the production possibilities frontier are equally productively efficient. PE, productive efficiency, sometimes called production efficiency, same thing. All points along the production possibilities frontier are equally productively efficient. So we can't say that, well, D is more efficient than G. Anybody can see that because we got more pizza and alcohol's bad for you and drunk driving and blah, blah, blah. No, all of these are production efficient, right? So in terms of an engineering, like we're using our resources, we're maxing them out. If that's the combination we want, that's the best we can do. 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 So kind of holding one constant, that's the best we can do. It shows the maximum combination of all goods an economy can produce given its available resources and technology. They're all equally productively efficient. Where are we going to be? Ultimately, we're only going to be at one spot. So my big but to this, but the economy will actually only be at one point. And that brings us to another form of efficiency called allocative efficiency. Allocative efficiency. Allocative efficiency is consumption at a point where the marginal benefit, which is where we bring in consumer preferences, where the marginal benefit, which we'll shorthand with MB. Some of you might have seen my sign out front that I'll explain in a little bit with my lit sign. Consumption at a point where the marginal benefit of the last unit consumed equals the marginal cost of that unit. I want to add that in, we can.
It's non-profit.
Excuse me?
It's non-profit. Or
Okay, we'll get to that story later. Turns out there's some profit in there because economists want to include some amount of profit as a cost because opportunity cost is included.
right.
Connor? Of that last unit. Of that last unit. So marginal cost. So consumption at a point where the marginal benefit of the last unit consumed equals the marginal cost of that unit. That's only going to be at one spot along here, and that's where we kind of decide where we want to be. And so the last thing I'll leave you with from this chapter is that point. I'm just going to generically draw that marginal cost curve that we had, that I motivated with the production possibilities frontier. So this time you can be a little sloppy. We're not using the exact same numbers. Just put an upward sloping law of increasing costs, an upward sloping marginal cost curve, quantity of pizza down here. The cost of pizza is going up as we consume more and more of it. And now we can think about the benefit that we get from society, which we haven't talked about. As you consume your first piece of pizza, your second piece of pizza, your third piece of pizza, your fourth, which one gives you more benefit to you personally? The first slice or the second slice? Which one do you get more gratification from, more benefit? The second one? Okay. Which one gives you more benefit? The second one or the third one? Like if you were sitting there chowing down in the lunchroom, you ate the first one, fine. Ate the second one, fine. Ate the third one. Now talk about that third one compared to the second one. Which one gave you more benefit, more satisfaction? The second one. What about the fourth one compared to the third one, if you can make it that far, right? You might be, well, maybe not all of us. I can shout out probably 4 pieces. Depends how big the pieces are. But that is an important principle we'll come back to later, called the law of diminishing benefit. The law of diminishing benefit. That's bringing in the consumption. And so the marginal benefit of additional units decreases. We can maybe make an argument that the second one somehow is better, but eventually that benefit diminishes. And I'll just kind of foreshadow for you where we're going with this, is that that's the marginal benefit, that's the marginal cost. The allocatively efficient amount of slices is here apparently at 2.25. Right? So we're going to have to take a couple bites of that extra slice and say, screw it, I'm full. Right? So 2.2, this is the allocatively efficient quantity for this consumer to eat. This is how much we should be eating, where the benefit of the last slice is equal to the cost of the last slice for society. And again, kind of a foreshadowing thing, just so you have it in your notes. Down the road, this is going to be kind of the supply curve. And this is going to be the demand curve. And so we're really starting to introduce you into supply and demand. But thinking more about the quantities, notice, and let's put that in parentheses because a demand curve has dollars over here, not beer. And I have beer still, right? You with me? So in terms of how much benefit I get quoted in terms of beer, then that's what we're talking about. That's a demand curve has dollars associated there. We'll get there maybe even yet in a little bit. Okay. Questions? Slopes. Calculations. Shifts. General awesomeness of the production possibilities frontier.
Oh, on that math, whatever thingy. There was a question that was asking about, let's say he runs for 2 hours.
Okay.
And he gets 90 in the test, and then he runs for 1 more hour, and it's up to a 70.
Okay.
I didn't understand like the wording of it, I guess. And it was saying that the marginal benefit is greater than the marginal cost.
So he's asked about a question, and I'm just going to ask it in general. We can talk more after class. But when you see problems in the homework, try to narrow down what is kind of on the vertical axis, what's on the horizontal axis in terms of the hours, and what's going up and what's going down, right? And thinking about what you're giving up to do another unit. So I'll just leave that as that again, kind of be careful with placing the right things in the right spot as you read a question. And we can chat more about that after class if you want. Okay, well that is chapter 2. And it's time to get into the law of demand. The law of demand So the production possibilities frontier was our first economic model, and then we're going to go right away into our second here with demand and supply. And so we're going to start off with the law of demand. As the price of a good goes up, what happens to the quantity purchased? Goes down, right? Negative relationship or positive relationship between those two variables? Negative. Price goes up, quantity goes down. Price goes down, quantity goes up. Moving in opposite directions. So that is the law of demand. As the price of a good or service, as the price of a good or service increases, the quantity demanded, QD, as the price of a good increases, the quantity demanded decreases. Now, is that true all the time? No. Why?
Factors of reduction.
What's that?
Like the factors that play into it. Just like exclusive.
Okay, other factors?
Exclusive items.
Exclusive items that are kind of hot, trendy, hard to get maybe, something like that?
What about a monopoly? Like something you have to have, but one thing controls it, so it doesn't matter what the price is, you still have to pay it.
Okay, so somebody has a control over it and can't, you can't get it, so it's either pay the piper or not. Marketing can influence that. Anything else?
Future.
Inflation? Is that what you said?
Yeah.
Okay, so with inflation, I want to be careful because as the price of a good increases, that is kind of the price going up, is the inflation I guess maybe what you're thinking here is that the prices of all goods going up, that could affect it, right? Because then we're talking about not only the price of beer going up, but the price of wine, the price of bread, the price of gas, the price of some more general rise in the price level. Okay, that's fair enough.
Are we just going to go over tribe or?
Over what?
Tribe.
Tribe, what's that? Is that a
taste and preference related to income.
Memorization thing that you had? We're getting there.
Environmental effects.
Nominal effects. All right, so we just came up with a number of things that might kind of make this not work, right? Some things that might make this not work. Well, what kind of law is it? I mean, when we say the law, doesn't it mean like yes, no, good, bad, evil, heaven, hell? The law of demand, it should work all the time. So this is actually false. So we're already starting off on a bad foot. I'm just putting up a bunch of BS up here. This is completely false, I assure you, the way I have it written. It's completely dead wrong. But I'm going to make it right. I won't want to let you down like that. Ceteris paribus. Ceteris paribus. Is that something in Harry Potter? Oh, you just think I did magic up there, huh? Poof! There, the law is correct. It's all is well now. All right, that's a Latin word. Anybody know Latin?
A little bit.
What do you pick up from that? I didn't mean to test your Latin, so it's okay if you.
It's been a while since like 7th grade.
Okay, wow, yeah, it's in Latin in 7th. Did I see another hand go up that you knew a little bit of Latin? Want to take a stab at it? Holding all other things constant. So in other words, this holds if the rest of the world freezes. And all those things that you guys said don't happen. Right? All those little extra components that you were doing, we're going to freeze those at what they are. Somebody said advertising. So if advertising was $100,000, advertising is going to remain at $100,000. Right? So we're going to freeze everything, holding all of the things constant. So ceteris paribus is holding all other things constant. And that preserves the law of demand. That makes this true. All right, so what kinds of things? So what other things matter? So I want you to think about your real life and on the decisions of the quantities of things that you buy. What are some other factors that kind of enter into the equation for you? Need?
Unit price.
Price, and we got price covered. So price is with that. So whatever the price is, that determines how much we're going to buy. So now what we're kind of doing is saying, let's hold price constant and tell me what would make you buy more of it, right? So let's take video games. How many people play video games in here? How many people don't play video games? At all, never have, never will. Okay, cool. All right, there's a few people that don't hit the video games. So price of a download on Steam is, I know a little bit of this because I have a sophomore in high school. What are you guys on average spending for a normal game downloading? $60. Let's go. That probably works whether you go run to Walmart and buy it for the Xbox or maybe you stream it. So $60, some sort of equilibrium price roughly for a cool new game. $60, right? So I'm going to hold that $60 constant. What are some things that would cause you to buy every single new game that came out? What would cause you to buy more?
Expectations.
Okay, expectations. Free time. How much what? Money you have. So in terms of income, like if you had a lot more money, whatever money is in your account, except if it's zero, well, maybe I'll just do an absolute, it'll be easier. Whatever money's in your account, let's make it $75,000. Would that change the quantity of video games you're going to buy? Yeah, right? So you probably got that covered. So one of the other things that matter is your income. Your income. 2. What did you mean by expectations?
Okay, so if a store says that this game is going to be cheaper in the future, you're probably going to wait to buy it.
Okay, good. So yeah, and this happens with downloads and stuff too, right? My son, he's been trained all his life, kind of the economic way of thinking, so he's hopefully not too jaded about that. But he's become pretty sharp on this, right? Is that what happens if you guys aren't the person who has to have the game? It goes on sale at midnight, and at 12:01 you're already playing, right? If you wait a month, 2 months, 6 months, a year, what happens to that $60 price tag? $20, used games. Yeah, there's a used market. You can buy it on Craigslist. Somebody already solved the game in 5 days. They're selling it on Craigslist for something else, right? So the price comes down. And so what was mentioned there was expectations.
But didn't you say prices frozen?
But expected price is not. That's a good point that you bring up. So this one is can be a little strange, and so if there's a decrease in the expected price, if you'll kind of bear with me, so you kind of know that after 6 months you can normally buy a game for $20, like you're saying, right? But now something has happened in the marketplace, and you've changed your expectation that it's going to drop to 20 in 2 months, right? So your expectation changed. What's going to happen to sales of the game today? They're going to decrease, right? Because more people are going to hold out. They're like, oh, I can wait 2 months. I couldn't wait 6 months, but I can wait 2 months, right? And so a decrease in the expected price leads to a decrease in demand is where we're going to go with it later. I'll explain some of my notation later. I don't want to jump the gun too much. This is the demand today. If you expect the future price to be cheaper, you're not going to buy it today. You'll buy it in the future. So you're substituting. You're doing the fancy word as an intertemporal substitution. You're substituting across time. Right? Instead of buying today, I'm going to buy tomorrow. It's like, whoops, I made that decision. An intertemporal substitution. All right, what do you got on that phone, big guy? So, nothing important. So remember, you got to shut your stuff off. So our first loser of a point is Tyler Bedford. All right, Tyler Bedford. All right, so make sure you disconnect yourself from the rest of life here. Okay, so that is a little different here with prices. All right, how about the price of related goods? Yeah, it is kind of competition, right? So we have other goods that could be competition, and those would be the price of substitutes. So we have substitutes. Let's see. I don't know if I can stick with my video game example or not.
So apples.
To what?
Apples.
Apples,
At
what?
one store it'll be $11, next store it'll be $1.20. So you probably bought one at Walmart or Kroger.
Okay, yeah, so we could use the retail side of life. All right, so if we've got, well, that's not really where I want to go, because that's changing the context. I guess it just gets a little more confusing to label it that way. So downloads versus actual discs would probably be a good way to look at this one. So if there's a decrease in the price of the downloads, what will happen to the demand for the, what do we call it, the discs? Is that the best way to say it?
Decrease in demand.
A decrease in demand. So people are going to buy more of these and then less of the discs, right? So decrease in the discs at places like Walmart, where you're buying the physical disc. Goods can be complements. And I'm not big on spelling in this class, but I want to call to your attention how you spell this particular type of complements. It's with an E instead of an I, right? So, hey, I like your shirt. That looks nice. You look nice today. That's a compliment with an I. This is a compliment with an E. And the reason I like to call that to your attention is that you can think of the two as completing a set. Completing a set. Peanut butter and jelly go together to have a sandwich, right? A golf club and a golf ball are complements. You use them together. You're completing the set or the pair of the things that go together. All right, so those are complements. Back to our game example. What would be a complement to the game? The game console. Good. So if there's a decrease in the price of the console,
And there's certain games that are only for that console.
and some games are only for that console, right? So if there's a decrease in the price of the Xbox console, right, what happens to the demand for the actual games, the discs that they go up, right? And downloads would go up too, of course, so they might both go up. So that leads to an increase in the demand for the discs at the store. Notice that these things are moving in opposite directions. So those things that we use together is going to move for an increase when there's a decrease because the price of the package has gone down. The set has gone down. All right. Number 4. The population. Now this one's a little bit one you might not have thought about as much. But I think the businesses on Main Street, maybe Pizza Time and Pizza Village and the movie theater and El Sol, El Mezcal, Luigi's, they're all happy that you guys are here. Why?
We increase the population.
You increase the population, right? So the number of bodies that are here went up in Ottawa by about 600 people, because there's not too many people. There's a few of you that stay and live in here during the summertime, so that's not quite fair. But we brought in more population, and that increases the demand for those goods. So the population plays an important role. When there's an increase in the population, that leads to an increase in the demand for everything, yes, in general. Okay. What else?
Taster preferences.
Taster preferences. So, oops, not tacits. Taste or preferences. So this is kind of a little bit of a, almost like wiggle room a little bit for the economist here is what causes your preferences to change? So what do you think happened to the preferences for umbrellas today, this weekend, for Labor Day weekend? They went up. So did some people, not everybody, possibly make a trip down to Walmart and buy an umbrella? Yes, because of the rain coming about, their preferences or their tastes for umbrellas changed. So we can have different factors that change our preferences. What else modifies or can change our preferences? Let me get some new people here. Let me get to the random number generator. Give me a number between 3 and 12. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Evan. What's your name?
Lydia.
Lydia. What do you think? What changes your preferences towards a product?
Maybe if like a newer brand comes out.
Okay.
Like, I mean, obviously I had a PC before an Apple computer, so.
Okay.
Then I chose an Apple computer because like this is newer and nicer.
All right, good. So that one kind of rides the fence a little bit on the price of related goods. You might have been, how'd you learn about the new product? And you're right, by the way, you're kind of riding the fence. I just kind of want to hide this down. What you said is okay. How'd you learn about this product?
Well, I needed a computer, so I went to a store and
Okay.
people who, like the Apple people knew about it.
All right.
About it.
And did you hear about it on TV, social media, or anything like that about new products? Probably, yeah, almost subliminally the way they work, right? They're kind of flashing up on screen. So yes, all of the things you said are correct, that they tend to modify our preferences. Our preferences could change when there's a new substitute that comes into the market that we didn't have before. So we've changed our preferences towards the good. And so if there is a new product that's being marketed by, who's the latest, greatest Hollywood superstar that everybody is just so excited about? You can see I don't follow this stuff like I used to. It's not Britney Spears anymore, is it?
Oh, yeah, Miley Cyrus.
Miley Cyrus. Yeah, Miley is pretty hot right now. All right. So some people are anti-Miley. Some people are pro-Miley. Some people are anti-Miley. She might not be the representative that we want for Bible sales, for instance. Might not be the best choice of celebrity. But having somebody push a product, if we're LeBron James, if we're some Derek Jeters out there, or if we're some Tom Brady's, having those guys endorse some tennis shoes goes a long way, doesn't it? Right? So having somebody endorse something can change our preferences to it. It might give some credibility to it. We might buy it and find that we get burned, but we learn from it.
Couldn't just like growing up and being older change our preferences, like we're not getting the same stuff?
Absolutely, yeah, that's a good point. And that is one that falls into this when economists start to do studies on whether this product's going to sell to a certain group, and so they might sample from old people, middle-aged, teeny boppers, and 20-somethings or whatever. So yes, absolutely. As age goes on, our preferences can change over time. Good. Your upbringing, the culture, all of those stuff kind of falls into this taste or preference. So you can see it's pretty broad, right? You can see it's pretty broad when events like the Twin Towers coming down, 9/11, did that change our preferences to national defense? You better believe it. All of a sudden people are like, oh yeah, I used to be kind of anti-government spending on weapons of mass destruction, but I think that's a good place to put some money now, right? It changed their preferences. Okay, so taste or preferences, just to give you, if something's in style, that might lead to an increase in demand. Our taste or preferences are often shaped by advertising and other information, which could include research. If the Food and Drug Administration comes out and says that oranges cause cancer, then that might shape our preferences a bit. Well, I thought they were going to be good for my eyes. Who would have known that it's going to create cancer? So that's what the latest scientists told me. So it wasn't necessarily advertising in the way we think about it, but some other sort of information comes to the market that compels us to change our behavior. Okay, so these are the things. These are the types of things that we held constant when we made this claim. Okay, so now we got to see what their impact is. And before I drift away from this, I wasn't really expecting to get into the D's yet, but that's kind of the way we go, whatever feels right. We kind of take it down that path. And so under income, I want to give you two cases, kind of like we did substitutes and complements. As your income goes up, do you always buy more of everything?
No.
What do you get rid of? Give me some examples of something that, you know what, I would never buy this if I had some coin in the bank and I was making 100 grand a year.
Payday loan.
Ramen noodles, payday loans at high interest, good. Ramen noodles. Other things? What are you eating now? What are you doing now that will be a lot different if you're making 80 grand a year? You're like, I'm going to be doing what? What, better clothes, right? A car?
Premium gas, I think.
Premium gas? I might be willing to spend a little bit more for premium gas. Good. All those sorts of things, right? So we have normal goods and inferior goods are the two types of goods that we have. Normal and inferior. With a normal good, this is how most goods are, an increase in income, I'll just use a capital I here for abbreviation on income. A normal good, an increase in income leads to an increase in demand. You buy more of that product. With an inferior good, like maybe the ramen noodles, some hot dogs, stuff like that, you start shifting into steaks and good, better cuts of meat, maybe less macaroni and cheese, right? So as your income goes up, that leads to a decrease in the demand for inferior goods. All right, so those are our two cases for income. All right. So let's see. Let's do a little example here. So suppose we look for the. Nope, we lost her and came back. That's all right. Sometimes the signal's not always good. So, oh yeah, it looks. You're good. Cool. All right. People want to talk to you, I guess. We'll see if we can incorporate some Sarah input here. All right. So, example. Let's see. Suppose we got the price of beer and the quantity of beer. Let's put on our schedule goggles. And we've got, at $12, we have 160 cases of beer being, this might be a case. This is a pretty expensive case. This might be a 12-pack or something. At $12, we've got 160 12-packs going out the door. At $10, we've got 200. At $8, we've got 240. At $6, price is falling, quantity's going up, right? The law of demand, holding all of the things constant. And finally, at $4, we've got 320.
Consistently going up by 40.
Yep.
Dropping by 2.
So go ahead and graph that. So again, try to keep your the spacing between these. You can kind of start your 160 wherever you want at $12. So I would go 2, 4, 6, 8, 10, 12. And then we can go 160. Boom, 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 boom. Just so we got a little bit of idea of spacing and what this line might look like. If you want, you can put a little squiggly mark here that says we're not really perfectly to scale. 160 and 12. Go ahead and graph that whole thing out. So Sarah, I'm curious, are you able to read those with the size of your screen on that end of the board?
No.
Okay, is it just real fuzzy or?
It's like really fuzzy, and I already have bad eyesight, so.
Right. Okay, I've had Sarah in a different class, so we've talked about eyes and cars and other things. She had personal finance a while back. Okay, so we got our schedule of numbers here: 12 and 160, 10, 200, 8 and 240, 6 and 280, and finally 4 and 320. Okay, if you drew this pretty carefully and you connect the dots, what should you find?
Straight line.
Straight line. All right, so I did that intentionally. And most of the time in this class, we will use a straight line demand curve for simplicity. In real life, that demand curve might have a little bit of curve to it. It might really be curved, but just as kind of a getting started and to keep the math a little more simple, we're going to be dealing with straight line demand curves. So there's our demand curve. And I want to think about what the impact would be if we had an increase in income. So if we had an increase in income, what would happen to this thing? Depends on what type of beer. I'm glad you said that. Why?
It's like cheap. You can on sell beer, then you want to before you can afford to get the next.
So we got Keystone Light or Bud Light, right? Which one? What are we talking about here? Which beer are we looking at? So are we an inferior good or a normal good? Let's say that we're a normal good. So if we're a normal good, what happens to this relationship of these points?
All sales go up.
Sales go up. What happens to the relationship of points? They expand. What does that mean? Go up. Shift up. See some heads nodding. It's kind of right and wrong at the same time. And I'm going to show you why, because this is important. It's mostly right, by the way. But for long-term thinking, I want you to think of it as a shift to the right instead of a shift up. Now, if you look at where the golf club ends up, it's potentially the same darn thing. And you're like, Russ, up, right, whatever, right? I'm with you. That's fine. But for future, when we look at different types of shifts, it's better to think right and left when we get into the interaction of supply and demand. So for now, just kind of trust me. But also the logic goes that way as well. What of these variables is the independent variable? I know I've thrown a lot of math stuff at you today with rise over run and slopes and stuff like that. Which one of these two things, the price of the goods, sorry I didn't label my axes here, which is an important thing to do. Which of these two variables is the independent good, or the independent variable?
The price.
The price, good. So the dependent variable is the quantity. Excellent. Now, wait a second. Math class. Y-axis, x-axis. Which one's the independent variable?
X.
The x is what that 5th grade, well, it might have been 10th grade, or depending on when you take it. Teacher taught you is that the independent variable is the one on the horizontal axis. So, I need to introduce you to a little historical accident, is what I'd like to call it. A guy by the name of Alfred Marshall is the first economist that really formalized the demand curve. And he put this in a footnote in his journal article. He put this in a footnote. He drew this little graph, and he put price up here and quantity down here, and it's stuck ever since. If I were to draw quantity here and price here, what would it look like? Would it go upward sloping?
Yeah, upward sloping.
Let's try it. Here's $12. How many are we going to do? 160.
That's the same thing.
$10. Ooh, yeah. Look at that. It would actually look the same. So there's no particular reason that economists have always drawn quantity here and price here, except for Alfred Marshall's seminal work that went on and it just kind of stuck. That's what I mean by historical accident. It's really not mathematically correct in kind of a fundamental way, but it works and we've kind of done it and now we got to live with it. All right, so knowing that, it helps tell the story of the shift a little bit better. So here is the price at $12, and you are currently making $20,000 a year. So your income is $20,000 a year. When the price is 12, there's 160 12-packs being sold. If the income goes up to 30,000, are we going to sell more or less?
More.
More. Maybe this much more.
240.
If the price falls to 10, with 20,000 we buy 200, but now we're going to buy more. At $8, I used to want to buy this much, now I want to buy this much. At $7, I used to want to buy this much, now I want to buy this much. At $11.59, I used to want to buy this much, now I want to buy this much. At $3, I used to want to buy some number over here that I can't see, now I want to buy this number that I can't see. Okay? At $5, I used to want to buy this much, now I want to buy this much. I used to want to buy this much, now I want to buy this much. I used to want to buy this much, now that I'm a rich guy I want to buy this much. This much, 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 this. As I keep doing this, what is this going to resemble eventually?
A line.
A line. And that's a relocation of the demand curve to the right. Right? It actually didn't shift up. Really, from what the story we're telling, which is a lot different than the X's and Y's, we're telling a story about human behavior. The price is driving the change in behavior, the change in the quantity of purchases, and so that demand curve is going to relocate itself to the right when our income goes up to $30,000. That is captured by this little up arrow with a D here. Which brings me to one of our other important distinctions, and that is the change in quantity demanded. What's the diff? What's the difference between quantity demanded and demand? What's the difference between quantity demanded and demand? This is the quantity of beer demanded at various prices. This is the quantity we're going to purchase at various prices. The demand relationship is this one floating out in space that is holding constant all these things over here, the ceteris paribus assumption.
So you have to take in like factors like waste and damage to the goods.
You sound like you're talking a little bit about supply of the goods. We're strictly looking at the consumer here, so on how we're purchasing it. It's kind of like a survey. Suppose beer's this much. How many do you want to buy? I want to buy this much. How much of it here? This one, this one, this one. That ends up holding all of the things constant, establishing the demand curve with all of the things, one of them being income being at $20,000. That is D, the demand curve. So this is the demand curve. This idea of the quantity demanded is that lives along the horizontal axis. So each one of these are the quantity demanded at a price of 12. At 10, I changed my mind and I want to buy 200. At 8, I changed my mind and I want to buy 240. Starting to see the difference here? So the quantity demanded lives along the horizontal axis. The demand function lives out in space here, this two-dimensional space that has price and quantity demanded associated with it, right? So when we live out here and we talk demand, we've got price and quantity. When we think about the quantity demanded, we're just talking about this level of space, one-dimensional space, the quantity demanded. So the QD is the quantity we want at a given price. The quantity we want at a given price. Anytime you guys in the back can't see like Connor did, and if you need to, of course, stand up, or if you need to vocalize and say, what does that say, feel free to anytime.
Hey, Russ.
Yeah.
Is this going to be on the YouTube channel that you have?
Yes. Yep. I have it being recorded on the other thing. I didn't want to do it this time, but I can also have this thing join. I'm recording on this one. I almost did it today, Sarah, but I decided we'll try it a different time. I can have this thing join the Zoom session like I did on the first day of class, and then Sarah can toggle between that view off that camera, or she can press a button on her screen and she can see what this thing's capturing. And that would allow you to see this side of the board better. Okay? Yeah. Well, I've ran this before with 4 cameras going, and my brain starts to scramble. Yeah. When I taught the MBA classes, when I had multiple people gone, I had multiple camera angles set up so that they could do that.
Like a GoPro?
Yeah, I could do that. That might be kind of fun too. All right. So here's the quantity demanded at each price. If the price of, let's see, what do we got here? Beer. If the price of pretzels goes up, if the price of pretzels goes up and my income is $20,000, what happens to the demand curve? Pretzelless. Left. Why?
Because you are going to be less willing to spend that much money on pretzels.
What's the connection then between pretzels and beer?
Due to the price increase, your quantity demand is less.
Yes, but I want to back up a step.
The same products.
Okay, what about those 2 products, pretzels and beer?
You're taking away from beer production by making more pretzels.
Nope, I'm not talking about producers again. This is purely on consumption. So this is all about the consumer right now. This is all about the consumer. Pretzels and beer, not everybody feels this way, but what might pretzels and beer be?
Compliments.
Compliments. Yeah, you get thirsty, more pretzels and beer kind of go together. So if you're one of those consumers, and you may not be, but as long as there's a few consumers who behave this way, and we have a population of 100,000 people, maybe we're in a lot bigger city than Ottawa, right? If the price of pretzels go, what did I say? Up. So if pretzels get more expensive, they're like, well, I'm not going to be buying as much beer. I'm just going to shift into some Jack Daniels now at this point. With my Jack, I just have meat sticks. So Jack and meat sticks. And so the increase in the price of pretzels causes you to buy less beer. And so if that happens, at $10, I used to want to buy 200, now I want to buy this much. At $8, we used to buy this much, now we want to buy this much. At $6, we used to buy this much, now we want to buy this much. And so I like you to think about the demand curve as a collection of points. I find that it's been misleading over the years for students to see this line every time. It's helpful if you think of it being a collection of points. What does that call to your attention if you think about it being a collection of points?
That is not constant.
That's not constant. Good. That. I didn't hear what you said. What did you say about responsibilities? There's multiple levels. There's multiple points, right? It kind of reminds you that, oh, this is a point. It connects with this and this, right? there's kind of that reminder that, oh, it's a collection of points. These are various choices at various prices. That's the heart of the demand curve, which is better maybe thought of as a collection of points. All right, good. We'll call it a day there. Have a good weekend. And